Hey, internet peeps, what's going on? How you doing today? I bet you're amazing. Or maybe you're like poop emoji and that sucks, but we're going to turn that around because you're tuning in to a new episode of AngularAir. I'm your host, Justin Schwarzenberger, and today we are going to be having some fun and games with ngRx. And it's going to be super awesome, I promise. Pinky swear. Can I pinky swear with myself? I don't know. Do I have to pinky swear with like somebody else? I don't know the rules of pinky swear engagement. It's been a minute, but I swear it's going to be good. So let's get into it. Our panelists joining us today, we've got Mike Brocky. Mike, what's going on? Mike. All right, how about Austin McDaniel? Austin, how's it going?
How's it going, guys? How's everybody doing today?
Cool. Hey, Mike, are you there with us now? Can't hear Mike, but he's here. And our guest today is Ken Rimple. Ken, how's it going?
I'm doing great. How are you?
I'm doing good. Doing good. Happy to have you. Why don't you fill in our viewers a little bit about yourself, what you got going on, what you do, that sort of thing?
Sure. So again, my name is Ken Rimple. I'm the Director of Training for Chariot Solutions. We're a Philadelphia-based application development shop. I focus a lot on AngularJS and Angular 2/4, whatever you want to call it these days, having written our own training in those areas. So a lot of, speaking, evangelizing, trying things out, educating the public, that kind of thing. It's a lot of what I do. And also when I'm not doing that, I'm helping our consultants on various projects.
Awesome. Well, we're stoked to have you here today. I understand you've got some ngRx code you're going to demo for us and show us some solutions that you did for a couple of projects. But before we get into that, let's talk a little bit about ngRx and fill in viewers who might not be familiar with it or who've just checked it out. What are we talking about when we talk about ngRx?
Sure. So ngRx is a Redux state store for Angular. And so let me unpack all that for you. First of all, before anything else, ngRx, the Rx at the end, really says that it's using RxJS, the observable framework that everyone is learning and using in Angular going forward. So it basically deals with a stream of information going from information stored in a state. Beyond that, it's using the standard pattern that's been put together by the Facebook team around Flux and then ultimately Redux, which basically states that you've got this collection of state, and the state is stored in a store of some sort, which is just basically some sort of object that manages it. When you want to make a change to the store, you dispatch an action to it. The action has a type, and the type has some sort of payload in it that you'll pay attention to. And the way Flux works is that you have a function that is a pure function that will always return the same result for given inputs, and that you're always replacing the state from what they call the reducer, the method that they're actually processing it with. So that's the basic architecture. From the other side of it, to use it, you're going to dispatch methods into it, dispatch these requests, and you're going to be notified through an observable whenever the state changes. And so that's the basics of ngRx store. It uses observables and the Redux pattern to store state for an application.
Okay, cool. So I want to talk a little bit about that when we talk about Flux and Redux and how it got to ngRx and what kind of that plays out with. But before we do that, let's talk a little bit about what is the problem or what is the solution that ngRx is providing us, or this approach of this state is providing us in our Angular applications.
Sure. So the good part, I think, about it is that you're kind of centralizing a graph of data to deal with that can then be subscribed to, again, through the RxJS kind of subscriptions, can be subscribed to in various slices across your application. And so it makes it so that the individual components don't have to manage a whole bunch of little tiny pieces of state themselves. They can all kind of point to a slice or a view of that state. And I think that's the real thing that it tries to address for you. The other thing that it does is it lets you chain in various types of operations. So for example, maybe you want to persist all of your changes as they're making them into local storage, or you want to write some sort of like middleware-ish kind of function that turns it into something else. You can do that. Or you want to log all your steps and see what's happening or debug it. you're doing that in one central location. And that way, essentially, your components don't have to worry about that. All they have to worry about is a simple dispatching of an action and getting an update of the model data they care about. So it's pulling it away from the manual process of putting things into individual services, perhaps, that each component is injected with, and dealing with a centralized tree of data that is viewed in different ways. Not all applications need that, but that's what the basic pattern is.
And that centralized tree, it's at the global level. So
yeah,
everything across the whole application can take advantage of that.
Correct. Yeah, and you can inject the store, which is the thing that you access the state from, and subscribe to pieces of the store from any component, any place.
And I think that's one of the big factors of it, the benefits of it, right? Is that as you start crafting in this component world and you get more and more components across your application, you need some way to broker interaction between them all, right? And communicate and react to these things and all this stuff. And so you now have to try and solve that pattern. And do you have components that know about each other and are coupled with each other? ngArx provides this way to decouple that. And now it's kind of like, okay, a component can live anywhere and do some stuff and affect the state, and other components can listen for that state and subscribe to it. And now you can have this inter-component communication going on without the deep coupling of the tree and the build out, right?
Yeah, correct. And the other benefit of course, on the other end is when you're subscribing to it, you have all those rich functional transforms it can do with it. You can map over it. You can, filter out the ones you want to see based on time or based on frequency, and do all the standard RxJS type of operations you'd like to do to the data that's being changed. So that's very useful as well.
And the other factor there is you're getting this new state, right? Which allows us to do change detection and more performance and stuff like that we get out of this new object coming back, right?
That's right. So an example of that is if you're, feeding an observable into an input of a component, and then you set the component strategy to change detection of on push, then it's only going to redraw that component when the input changes. And since observables, every time they fire, change the input, it follows then that works pretty well for limiting the change detection processing. I have an example of that when we look at the little net hack thing I was hacking around with, the little player movement thing of turning it on that way. The other thing that goes really well with this in terms of the architecture of the actual state tree that I've been experimenting with over the last couple of days, and I see a real advantage of, is Immutable.js. Just in terms of the mechanical management of state, whenever you're, and anyone who's done any kind of Redux research has learned the big giant object assign methods that get really long and ugly. If you're dealing with Immutable.js, every time you quote unquote mutate, you're replacing the state with a brand new one. So in the demo I'll show you a little later, I'm using Immutable.js for all of that to make life easier ultimately for managing that state. So you should always be replacing state in the reducer. And that means that is the thing that triggers the change detection of things that are fed from that.
And for the listeners, Immutable.js is a library, I believe it's by Facebook, that basically helps you maintain this immutable state. So in order to access the objects, et cetera, you have to go through their kind of API, and it prevents mutations. And it also has a lot of helper functions, like you were saying, around like, I just want to update one property, now I have to do these, expands on the object, et cetera. And this can really help you out with that.
Yeah, it was interesting. I'm sorry, go ahead, Mike.
I can talk, you can hear me. Yes,
Yay!
Success. Yay, internet. But just wanted to clarify again, since we are mentioning Immutable, that it is optional. You don't necessarily need to use Immutable.js in order to create and work with immutable objects. It's just, like you said, it provides nice helpers for maintaining and working with immutable objects, but you don't necessarily need that if you're very secure and confident that what you're doing is immutable work.
Yeah, that's the key. And so, for example, I built this drum game without Immutable.js. And then I looked at the code, and I'll show you some of the slides. So the code, I mean, definitely it's something I was hacking on to learn the technology more and to sharpen my sword, so to speak, in discussing things. But there was a lot of state manipulation there that would have been made easier with Immutable.js as the object API. So I think you'll see differences as we start talking about the mechanics of managing it between doing it just flat with plain old JavaScript and object assigns, or news on things, versus basically getting Immutable to mutate something by creating a new one. That makes sense.
Yep. So let's go back really quick and talk about that journey of it going from this Flux to Redux to NGRX, like how NGRX came about, kind of taking from those guys and learning from this solution that got put in ahead of time. If we can just give you a quick rundown of that.
Sure. Well, I hope I get the sequence right. But so the concept, I guess, with Facebook was originally to have a state store, and Flux was more of a general state store of you will have reducer functions that change state. And I think the major innovation with Redux, if I remember correctly, is that Redux was the one that said the state must be immutable. I could be wrong about that, but I'm pretty sure that was the pattern. And so I think that around the time that Angular and RxJS were coming together, the team that was working on these projects that ended up becoming ngRx Store, I'm pretty sure they looked at that and said, if we make observables the heart of this, we basically make it so that everything is very reactive and very native to the Angular ecosystem. Now, I'm not so sure that that's the actual true story of how it evolved. I don't know if anyone here has a better story on that, but it certainly came about. I learned about it at ngConf 2016 and saw a really good presentation. I think Rob Wormold had it, and also heard a little bit earlier than that the Everything is a Stream presentation. That was the RxJS stuff, and then ngRx Store he brought to ngConf 2016, if I remember correctly, to show off. So I started looking at it about the same time that I was working on some training around React and Redux. And then kind of put it in the back of my mind and said, we're going to come back and look at this later once we get this React training out of the way. I wanted to take a look at doing a Redux pattern in Angular and see what happened. And it just so happens that ngRx Store is there. I also know that there's also an Angular Redux project out there, NG2 Redux. Has anyone here ever used that?
I have not. I've spoken with the maintainers a little bit, but I have not personally used it.
Yeah, because I mean the Redux pattern is, I think it's under 100 lines of code if you, or close to it, if you write the pure Redux pattern yourself. And so the RxJS store is just one mechanism of doing it, but you could certainly do it with just a straight API as well. So, in fact, there are some developers just decided rather than build their stuff with the Redux API, they just build their own reducer and their own store pattern. So the concept is relatively simple. It's just, the tooling that comes around having a standard API is what could be really beneficial.
And is Flux more based on multiple states stores, and then Redux is like the concept of one state store that you take slices from? Is that one of the things?
I'm not entirely sure because we really only covered Redux. The one thing about Redux, and also that Angular follows with, is that the store can be partitioned. So you can decide, and I don't do this yet. I've been trying to find good use cases besides just building up an enterprise app kind of thing, of having true, hard slices of data. Because what I always find is, especially with the NetHack game, was I'll need to find information out from one part of the tree in another reducer. So if you break it apart, you don't see that other state. But the concept is you can partition it by some key, and each reducer, each function can manage a particular subtree of that data. And so I'm not sure if Flux was, 7 different fluxes out there versus one Redux with 7 different keys. But basically, ngRx Store follows the latter, which is I can have one store that has multiple reducers operating on different keys. And there's an interesting thing that happens when you do that, is that your actions can cross-cut across your different trees. So you may, if you want to think of it as like a save action or initialize action, each of the reducers with their own tree of data can deal with a more generic thing in their own way for their state tree of data. So the advantage of having it all rolled up together with one dispatch process is you can do that kind of stuff.
Yeah, definitely. I think that's that concept there, right? Is that you're selecting slices that you need, but you have it all as one. So just like you said, you can run over all of that.
Right.
One of the things that I've done is I've partitioned it out with like a UI segment and then a data segment, and I can have just stuff that affects my UI, things that are showing and hiding or animating or whatnot, loading, that sort of thing. And then the things that are part of the data, and then you can slice into it and kind of organize it that way. So that's kind of something that I played with as well. And one of the ways that kind of, because another thing that you can do with the state that you talked about earlier is that now you have this ever running, snapshot of what your state of your application is. And at any time you can grab that snapshot and then rehydrate your application with that state and get it back to that same state, right? So you think like a browser refresh or something like that. And things like, segmenting out your store can allow you to do things like, okay, these are the chunks, the UI or whatever that I do want to rehydrate. And this is maybe the data that comes from a service that I want to rehydrate by making that call and putting that into the store. So that can help there.
Yeah, right. Makes a lot of sense. Sure.
I've even heard some people of using, the store for some type of cache mechanism with your data layer.
Yeah, that makes some sense too. So there's a lot of good things you can do around this. And I think that there is a project out there, like an ngAir middleware for example, persisting to local storage, which is one of the projects you can just install into the kind of the Redux processing model. So that's the kind of thing you can do. And I'm not entirely sure, this is one thing I'm a little unclear on, is how much of the Redux middleware could be compatible at all. I know that, like, we'll talk about tooling a little bit. They actually do have an ability to use the Redux dev tools, for example. But the one thing where, for example, Redux has a very large number of things that I don't see in ngAir is all the different middlewares. And the middlewares are things that do all sorts of transforms to the data or processing the data. And I'm not sure how compatible they are.
I haven't tried it myself, but I've seen other people use pieces like Reselect and things like that.
Oh, nice.
And so, and with its hook into the store, I assume it's probably got to be compatible, but I've never done it myself.
Yeah, my gut feels the same. That if the dev tools work, that's pretty much observing state changes, and they're a compatible state change model. You would hope that you could do that. But I was researching that for the show. I couldn't really find much on that. So that would be really an advantage if you can do that.
I think that was something that they had in ngRx, and they shelved it for a while. I think I was talking to Mike Ryan at ngConf, and he was mentioning that he wants to get back on the show here and talk about some of the new stuff that they got coming out with it. And I think that was something that they probably held off on. I know the documentation showed some middleware type of concept stuff, and there's ways that you can do it, but there might be something new coming out that makes it easier for us to add that in. But along that topic, so there's different packages, right, for ngRx. You got the core and the store, and then you've got some of these other things like effects and things like that, right? And I think that you're going to cover some of the effects stuff here in a demo. Is that correct?
Yeah. So I used. So let's talk about some of those things. So the core of it, the actual core API, enables the store itself. So you have a dependency of the core and then the store itself, which initializes your state store. And pretty much most of the things you could do with that, you can dispatch an action, process the action, and get the subscription to deliver updates. That's what you get out of the box with the tool, with some really useful APIs in there. But then if you want to observe what's going on and watch the state stream and then react by kicking off another action, that's what these effects are. So here's an example of something you can't easily do without basically going out and in constantly to the store. What if you want to do a countdown timer? For example, you've got some sort of animation of a missile you're firing, and you want to be able to have it every 300th of a second or every 50th of a second. You want to have it move across the screen. To do that, you would probably have to set up some sort of set timeout and dispatch actions over and over and over again from the outside. But you kind of want the state store to manage some of these things if they're kind of activities. So one thing you could do is you could watch for a particular request coming in for an action that maybe says fire missile. And then what you could then do is have the effect pick that up, turn right around and trigger an animate frame kind of thing. And every time it sees animate frame, you could keep track of a number, decrement it until you get to the bottom, and then just shut it down. And that's the kind of thing you can do with ngAir effects, is watch for a particular message and then react to it by doing one or more things, or swallowing that message, or doing something along those lines. So the ngAir effects library kind of sits and observes and acts upon messages by then communicating further with the store.
And that allows you to take some of that logic out of the components, because normally the components are the ones that need to dispatch that, right? Or maybe a service, and pull that out and say, oh, this is not really tied to any component or a particular service, but I do need to do this workflow.
Yep, exactly. I do this in the game too. So I have a drum legend game that I'll demo here. And in the drum legend game, I'm going through various levels, and it's a real simple game, but you're basically stepping through 25 different more obnoxious drum patterns for drummers. And as I'm doing that, I'm kind of using the effects library to say, okay, start the timer. When you get down to the bottom of the timer, move the level forward, start the timer again. And it was really helpful. Before that, I was doing exactly what you talked about, which is writing a lot of code in a component. And I felt this just doesn't feel right. And then going back and thinking about the Saga library from Redux, which is what it's trying to do, is these long running stories watching the event, basically the event processing and then affecting new events. There's a library in Redux called Saga, which does basically the same thing ngAir effects does. And so that's where I learned that was possible. And then I looked and saw that effects was there and I could take advantage of it. So it's kind of good to learn both, to pick up the ideas from one group to apply to another.
One thing about effects is you can actually use Angular's dependency injection, I believe, with it. So if you needed to, in reducers, you can't, those are pure functions, so you don't have access to those injectors and things. And with effects, you can actually get instances of your services and perform, API actions based on that as well.
It's similar, Austin, to like the Thunk libraries goals in Redux, same thing, right? So in the Redux world, you want to affect an AJAX change to save something or pull something in. So you dispatch an action that says, I want to save this. And the action basically in their world returns a promise, and you do the AJAX call and the promise says it worked, or here's the payload, and that fills in the Redux data. That's the same thing here, you're right. So you're basically creating an injectable as your effects object. And yeah, you could certainly inject it in the constructor with whatever service you want. So that makes a lot of sense.
Yeah, that's a really good point in terms of what effects gives you, right? Versus your normal reducers and how it solves another problem with that. So very cool. Well, let's get into, I want to get into demos. I'm sure everybody wants to check this stuff out, but give us a real quick backstory of this demo and what when you do with that stuff.
All right. So I didn't talk about the New York thing online yet, right? We were just talking before. Okay, so the way this all started was, I was finishing up this training in React, and I had some time to do some more dev research for updating the Angular training, and I wanted to have an excuse to use RxJS originally. So the first thing I'm going to show you just briefly is a little synthesizer demo, and that's using purely RxJS. And I wanted to see if I could take MIDI input from Chrome, or device input from an IoT device like this goofy little conducted touch board. If I could take that information and I could then automate calls to service calls to do web audio, what could I get away with? How much could I drive the system and how reactive could it be? And so the first test was that. So I don't know if you want to share the screen over with me or give me presenter. I can share my screen. So let me do that. All right. Yeah, I have the Hangout toolbox on here. Tech support, there it is. Screen share, we'll do the entire screen. All right, so the first one is this polysynth thing. Excitement, right? But so the idea is it's just a web audio synthesizer, and I was able to do various things, like for example, these are my drums. And if I had a touch screen, this would be really cool, but it isn't. So I don't. But the point being that you could automate this audio, and then let's see if this works. So if I'm lucky, this works. I'm recording. It worked. Look at that. And all I'm doing is I'm basically replaying then events that I'm recording in web audio based on their timestamp, and that's all done through just pure RxJS. So for that, let me pop over here.
Wait a second. Can you explain what you did? You mean you recorded your actions and then replayed them?
Yeah, so I'll go through all this, but basically the first thing was the keyboard is simply just events, right? These are just press down events, right? And these are all using the Web Audio Synthesis API, but the drum set is just playing samples. And then what I did was I decided to take an RxJS feature called the replay subject, which is a type of observable. And as I'm placing things into it, it's basically a log of all the different notes I was playing. So I would record into the replay subject, and then for playback, just subscribe to it. And each of the events has the delta of time from when it started recording. So it would just basically feed those with a set, set timeout, I think, of the next interval play a sample, set timeout, play another sample, set timeout, and so on, and build a really simple, cheesy, but simple sequencer out of it. But this is all purely using just RxJS observables. And point being that I did this, and I went to Google and demoed this, and we had a really large response because, you know, probably about 60% of people I've ever run into in tech are either artists or musicians. And so they all swamped me and said, how'd you do that? And I realized I had something that people were interested in. And that's what led me down the road of going to NGRX store. But at the simplest level, what this is doing is basically using observables. So what I'm doing in this little piece of code here, I'm just going to make this a little larger. This is the MIDI input service. Is I'm actually asking Chrome, and believe it or not, Chrome has a MIDI API. Who knew? So if you've got a MIDI drum set or a MIDI keyboard connected to your computer, when you ask Window.Navigator on Chrome to request MIDI access, you can then grab the input and subscribe to it. So ultimately down here, I'm subscribing to that input in the MIDI API. And then as I'm getting notes in it, you know, I'm basically either doing a drum set or a MIDI note here. Where's the process? This is a little bit crazily done, but here we go. So I've got a process music note message, and this is based on the MIDI note number. So 144 is note down. 128 for MIDI is note up. So you can trigger a synth note message, and I have different just TypeScript variables representing different types of messages I want to process. And I'm feeding that into an observable. So one does synth note on, one does synth note off. One, if I turn a volume knob, changes the volume. I have waveform changes from sawtooth to, you know, different types of things. And then for the drums, I'm doing the same kind of thing. I'm basically creating a trigger sample message. So the one thing that doing just in general RxJS did was let me create a message channel that had typed messages because we're in TypeScript. You know, if I went into the app, let's see here, go to models. Where did I put this stuff? Should have thought ahead. But anyway, so I had somewhere in here, I had variables for the different types of messages. And then based on that, I would send these to an observable. Then on the other end of the pipeline, let's see, where was this here? Synthesizer service. Basically would play different messages based on messages that came in. I'm not actually, I should have prepped a little bit better on this particular block of code, but it's not really the focus of this whole discussion, but I wanted to point out at least this is all doing purely observable stuff. And the interesting thing about that was it was able to keep up even with a MIDI keyboard. So I was able to, like, you know, hook a keyboard up and play it and jam all sorts of notes into it, and it was able to keep up. But the coding for it was a little bit complex, A, because web audio is pretty complex, and B, because you're doing RxJS with web audio, and it's a fair amount of, you know, wiring to get it done. But it worked, and that was kind of interesting. Go forward a little bit, and we had this app. And so this was just an excuse to get people to walk into our booth at South by Southwest. We're do a fair amount of Internet of Things projects and mobile projects. And a lot of them have kind of wires hanging out of them, so they're not as exciting to look at. So I wanted to have something that people could engage with and kind of walk up to and, you know, tap a drum pad. So what I did was build a little drumming game. The idea is you get a challenge, and you keep going on forever, apparently. 15 seconds is an enormous amount of time, isn't it? And as you're doing this challenge, your score goes up, and then you go to the next one. So the second one is double stroke rolls. And as you're typing or as you're tapping on the MIDI, you're scoring points. That's the entirety of the game. But for that one, I chose to use NGRX store because it actually made the state of the game easier to work with. So here we go. So we've got a state machine for gameplay. And so what we're doing there is we have this tree of data called the gameplay state. It's an observable that we're subscribing to from the state machine. And whenever we do certain things, we dispatch actions. So for example, you know, we can send a stroke in, right? And that dispatches an action called stroke action. And that'll be basically left or right keystroke. And then the reducer has the state of the game in it. So in this case, I didn't use anything beyond standard ngRx store. So I'm creating an object for the initial state, which is of type gameplay state, and I'm initializing all the values here. And the drummers call different patterns rudiments. So I've got this concept of different rudiments I take people through. And so we step through them one by one by one. Now here's a reducer in ngRx store. Let me just move this out of the way here. And so the gameplay reducer is what runs whenever we send a message, whenever we dispatch an action. And you can see we have various types of things that we're doing. And so typically what you'll see with these reducers is you'll see an initial function that has some basic switch in it that says, based on this particular action type that comes in, I will do this piece of processing. And that we can start breaking things out and debugging them and working on them separately. And so you'll notice that in a lot of these cases, they end up with some sort of object assign. And so that's the general pattern, is return a new object, which is what object assign can do if you give it an empty object in the first argument, and overlay its values with properties from other arguments. So the state that came in from the last action is fed in. If I end the game, I say create a new object with that state and set the game play state to final score, and we know it's finished. And let's see if ultimately this will end, and you'll see like a score of all the different values of, you know, which level I had what score for and things like that. If the state comes in where it's send stroke, we go to this process send stroke, which let me go down there. So we do kind of some game state check. We make sure that the pattern that came in is proper. So, you know, as I'm typing, each one of those is a send stroke, and I'm basically concatenating that with the pattern. I make sure that the displayed pattern matches. If it does, then we increment our score, or at least increment our position. If it doesn't, then we reset and we start again. So that's the kind of logic we're doing in here. If we match all the way to the end, then I score a full match for that particular thing. We add to the points, and then we start the position over again, that kind of thing. Then ultimately in that one, we create a new object. We say gameplay state with the value state, with the current score values that we picked up and whether we moved on or whether we haven't. So that's that one. It's just just matching and following along and changing the state as we go along.
Very cool.
Let's see. And so with that, I installed the state store. Let me find the actual state installation here. State machine module. Let's talk about how we actually install it. So there is a provide store function in the ngRx store module, and this is where we talk about, you know, how you basically partition pieces of the store. So I only had one piece in here. I was looking for an excuse to do more, but I had a gameplay partition, and that was going to run the gameplay reducer. The gameplay reducer, the thing we just saw, we just export as a function, which we then import into the thing that configures it, which is in our case is a module. So store module.provide store initializes the store. And then basically that is the thing we can then pick up and inject ultimately and use to get to the store and do dispatches or subscribe to data. The effects are the things that kind of pick up when events happen. So for example, this is what the effects library is at a bare minimum looks like. We're going to have an injectable. And the injectable at the bottom has a constructor, which is given the stream of actions that are happening that you can then sip from. So you can say, as you see just above here, trigger timer, do something when the action type is action types.next pattern. And then it also gets the store itself. So those are the constructor arguments. And now I can affect changes by calling different things. So let me just go to a simpler one. Let me do start timer. So on line 32 here, we have start timer. And this is basically an effect that gets triggered when the action type is action start timer. We're actually not going to do it in the reducer. We're going to do it here in the effect. We're going to then take the information. we're going to use something called map to payload, which says, give me the parameter from start timer, which is going to be the number of seconds for that particular challenge. So that's what map to payload does. It runs this to payload function, and it takes that and makes that the result of the next call, which is going to be a switch map, which we've now switched what we're doing to point to the payload, which is the number of seconds for the timer to run. Some of this stuff takes a little while to kind of think through, but basically map to payload gets the parameters from the action you've just kicked off. And then switch map lets me change what we're doing so that we can then say, I'm now going to process this payload and I'm going to return a new observable instead. So I'm going to now run the timer decrement action with that payload. The timer decrement action gets triggered here. And what it's doing is it's just basically ticking down by 1 each time after sleeping for a certain number of milliseconds. And that's just some static configuration value. If we get to 0, then I do a score of the pattern and I trigger the next pattern. So that's letting me do 2 dispatches, one after the other. If we are still counting down, I just say, fine, dispatch another timer decrement action, subtracting 1 from the payload. So if this started at 30 at the start timer, it'll go to 29 here, then 28, 27, 26, down to 0, and then it will score the pattern and move to the next pattern. So those are the kinds of things I was able to do with the effects library that weren't easily done with Redux itself.
So I have a question for you real quick.
Sure.
So on that one, on line 48 there, where you're concatenating that observable and firing off those 2 actions, are those 2 actions designed to be independent of one another? Or do you know that? Are they fine to run like that? Do they run like what's the timing?
I'm pretty sure they have to run in order. Like I think that the changes to the store have to be done sequentially. From what I just from a concurrency perspective, we don't really have parallel threads, right? So it's going to basically take turns. Oh, great, I have a Facebook message. But it basically will take turns. So it will do the score pattern action and then the next pattern action, one after the other. That's my understanding of it.
And then it's getting a little deep, but do you know if that is dispatching that action and running that through all of the reducers and then dispatching the next action and running it through all the reducers, or is it running both of those at once?
It should be running them sequentially, one after the other. Now, hopefully I'm right about that. That's why I use the word should be. But as I'm observing, I've never gotten it out of sequence. That's the good news, because it's scoring and then it's flipping the next pattern. So it does look like it's sequential. And plus you're in JavaScript. So you're basically taking, things turn after turn. The thing I don't know is, does it give it any time to sleep between the score and the next? Whether it's like doing it and then taking the next one on the next tick of the JavaScript queue, so to speak.
Okay, cool. And then, so with the effect, you have a property on this class here, right? Like this one countdown timer, and you're setting that equal to a value, and then you're using the effect decorator, and that's what's going to have the whole library know that, hey, this is something that I want you to run and watch and do that sort of thing. Is that
correct? Yeah, you have to annotate with that effect, and so you're annotating a member variable that ends up becoming this operation. So that's the kernel of the game is that. Everything else is window dressing. But what I want to show the components at least, because I want to show it from the other side, right? So it actually turns out to be a simple component. So let me find it here. I'm in the wrong tree, aren't I? No, I'm in the right place. Drum Legend, source app, Drum Legend component. There it is. All right. So the interesting thing about this one is, most of the game is rendering, right? There's really not, there's the summary, by the way. Most of the game is rendering, right? The game plays all on the keyboard. And then we're just reacting. So this stuff at the top here, the timer's counting down, the score is changing. We've got these different pieces, and then we've got kind of some narrative. So that can all be pretty much handled with just a subscription to the root tree. And that's all I really had to do here. So for example, you'll see a template that's kind of broken down into different pieces, just CSS based blocks. You'll see I'm referencing things like gameplay state. And I'm being safe with the question mark, the Elvis, because it may or may not be there in some cases. And then it looks like I just went up and, as this was a demo, I was kind of hacking a bit and just did the brute force mechanism, right? Show the div completely or don't show it. So there's a little bit of, I guess, sloppiness here. But in the end, we've got this drum machine service in the constructor and the gameplay machine. And what we're doing is up top. Where is it on here? Oh, it's the app. That's what it is. I'm sorry, folks. App component's kicking this whole thing off, isn't it? Drum Legend container component. That's it. The container is doing the pipe to async. That's what I was looking for. So we have the content container mounting our main component. Our main component is given the gameplay state. The gameplay state is piped to async, and the async pipe will subscribe for me automatically and feed that into the input of Drum Legend main. So now Drum Legend main is merely getting a new object every time the state changes, and that causes it to repaint itself. And for this app, that's fast enough, right? Oh, that's a crazy one, right? But for this app, it's fast enough to do that because it's basically just mostly read-only data. But you could decide if you wanted to take slices, and I'll show you this in the next demo. You could take slices of that state and subscribe to them asynchronously, and have pieces of the page rendered just for that little tiny piece of state. But the bottom line is this does the subscription of the observable, and the observable is pulled in by basically asking for the gameplay machine's property, which is the observable of the gameplay state.
Cool, makes sense.
It's a little bit incoherent there to describe, but bottom line is you got these functions that are running whenever we trigger events. Oh, I should mention the triggering the event too. I'm using a host listener. So on window key down, so anywhere in the window, as long as I press a key, I then get the key, and this drum machine service trigger stroke and the send stroke. The interesting thing about this game is that the state of the gameplay is done through ngAir store, but the synthesizer that triggers the sound is done through regular observables. So I basically got two actions here. This one makes the sound, and this one keeps the game in good state. I probably could have done this through an effect instead. So the effect could have done both of these pieces instead, and it would have been just one simple dispatch to the action that would trigger the effect to then trigger the stroke and send the stroke.
And that's a good example of what ngArx is providing you here, right? Is this opportunity to do that, right?
Right.
With this effects, and now all of a sudden, now you can make this component slimmer because you can offload some of that logic out to now the ngArx stuff.
Yeah, it's always a challenge to work on these little examples too, because you're kind of woodshedding or learning from your hacking exercises. Then you look at it later and go, "Ooh, should I show that?" But it's a good learning experience. Like you're right there. That's a place where we could just say that really doesn't belong at the component level. That belongs at a level nearer to the state store. So an effect would be a really good thing for that. Absolutely.
Yeah, it's all about getting in there and starting, and then just refactoring.
Yep.
And that's a great thing about talks like this, is that it shows examples of the different use cases of not just, hey, there's effects and you can use them, but more so a specific use case of, all right, this is how you use them, this is when you use them.
Exactly. Yeah, there's nothing wrong with learning from the things you're doing. So then here's the silliest one I came up with, and I did this one on purpose to say, how could I make a relatively, hopefully, simple example of ngArx, completely ngArx store-based with an effect. And so what I have here is a really simple little play field. And the $sign, which is really, I designed that myself. And that's the player in this play field. And if I fire a missile, the missile firing is really an ngArx effect. And this other stuff is simply ngArx store. And I use this one as a chance to try to work on using Immutable.js as well. I wanted to see how much easier that could make processing the state. And so this is the third demo. And so this one, let me walk you through this. Just close all these things here. In this one, so I've got the board reducer. And so basically it deals with an array, a two-dimensional array of board spaces, rows and columns. And so this first chunk of data here is just initializing a set of rows and columns in a JavaScript array. And then I'm using Immutable.js. So this is the thing we talked about from Facebook here. And we're creating basically a tree or a map of objects. So this would be our state. And this is what the board is comprised of. It's basically got a player location, it's got a missile location, and a set of board spaces, or an array of board spaces. And so what I did here is I used immutable.map so I could get keys and values. So now we've got an immutable map with a key of player location, a key of missile location, a key of board spaces. The player location is a set of properties, so that's another nested map. The missile location, again, another nested map, and we've got row and column, and in this case, active. I want to disappear when it's not active. And then board spaces, again, it's a two-dimensional array. It's an array of board spaces. We have rows and columns. So that's the state. Now, the reason I used immutable was because it made modifying it a little more direct and a little less hard to mess up. And it wasn't, I was kind of surprised that it became much nicer to deal with. So here's the board reducer. We basically just got a couple of different things in here. We've got a fire missile effect, which you saw when we kicked something off. We have an animate missile effect, which we run until the missile dies. And we've got a destroy missile, which basically erases the missile. So that's the 3 for the missile. And then we've got a set tile to set the tile value. And we've got a capturing the movement keystroke thing for the up, down, left, and right, and fire. So those are the different types of actions we're going to do from our reducer. Let's go down to just the setting the location type. That's the simplest one. It's right there. Function set tile in. So in this case, we get our current state. We have a tile action, and the tile action is going to have a property of the space type. And so what we're going to do is we're going to grab the actions payload. And so in NGRX store, you have a payload for your action. You have a type for your action and a payload for your action. The type for this was set tile in. The payload is going to be basically an enum. So I'm using an enum to parse that out. And you'll notice my little comment, oh God, TypeScript. I'm a Java guy, right? In Java, enums are relatively straightforward creatures. But to decode an enum, that's a little bit of work. So you kind of have to like look it up by its type after grabbing it. It doesn't give you a raw enum. You have to actually ask it for it almost in index property syntax. So this is giving me the actual enum for the value in space type. This is actually 0, 1, 2, 3, 4. This thing turns it into, the type of player or whatever. So I code it back up to that. And then I create a new space object of type board space with that enum. And then here's the magic. Okay. So when you do set or set in a Immutable.js object, it returns a brand new object for you. I shouldn't say brand new, but it's certainly a new object. And so set in would say, I'm looking for the property chain of board spaces. The second part of it, because board spaces is an array, is the index of the outer array. And then that's an array of arrays. And so the index of the column in the column array of the row array. So it's a path, right? This is basically saying, give me board spaces, bracket, row, bracket, bracket, column, bracket. And I want to override its value with this new object. When I do that, it brings me a brand new reference with the updated value in it. And now I've got my mutated state. That's a lot cleaner than the whole object assign thing that you run into otherwise. Animating a missile or firing a missile. Well, let's do move player. That's another interesting one here. So moving a player, we're going to have a particular direction of the payload, up, down, left, or right. And so if we're moving it left to right, we're moving column-wise. And so in that case, I can grab pieces of the state, like the current row, the current column. And notice I'm using the state.getIn. Go to the player location, and the player location has a column property. So this is give me in the path of player location.call, bring me back this variable. So now I know what column that the particular player is in. Then I can do the same thing for the row. And then I do a little bit of math and goofiness around the player to figure out where I'm going to place them. Bottom line is I'm figuring out the target column, and if it goes off the left-hand side, I want to put them on the right. If it goes on the right-hand side, I want to put it at position 0. And then I do, yeah, go ahead. I heard a question.
I was going to say, it's important to note there, like when you're using Immutable.js, you actually, to get, your properties out of the object of the immutable state, you actually have to use the get in. You can't use like your traditional dot notation there. So that's one thing to note about when you're picking and using Immutable.js. It's kind of a whole mechanism. So not only are you setting state, but the way that you have to retrieve it is also different.
That's correct, right? So there's get and there's set and there's get in and set in. You're absolutely right. So then
is that returning a copy then at that point of that data, or is that actually reaching in and grabbing the reference to that data?
Oh, you mean for here? This, I don't know the answer to that. I wish I did. I would hope it's a reference to it, that it's something wrapped inside of it. You're just getting the wrapped reference, but I don't know the answer to that. That's a good question.
And also, like Immutable.js gives you the opportunity to get this object that you can work with, but then you can't mutate it, right, without using these gateway methods on that.
Yeah, correct.
So I wondered if get-in gave you a reference to that, and then you go and you change current call to be something else, or are you actually mutating that underlying object?
So based on that statement, you probably couldn't. It might throw an error. Who knows? I really honestly don't.
Errors. It does throw errors.
Okay, good. Well, that's good. You don't want it not to, right? Certainly don't want to mutate it. But
and that's the value, right, of Immutable.js. If you take this approach, is that now you're giving your people that write that code in there this rigidity of saying, okay, because it's really easy, I think, as you go forward for people to come in and not really realize that, oh, this thing that I'm working with, I could mutate that, and that kind of breaks down this whole Redux, ngAir pattern that you're using. So this kind of safeguards that a bit, right?
It certainly makes sense to do that, yeah. Well, here's another. So speaking of that, so what we ended up having to do when we move something from column to column is I want to keep track of what I know is the reference to where it is in the player location, right? So the player location has to change, but I also have to change the player piece, right? So that's 3 basic changes that I want to make. And so they have this nice little method on your immutable objects called with mutations. And the idea is that you would just chain different mutators. And what normally would happen for each of those set ins is it would return another state object. But I just want to batch them all together and get one final state object. And I found that incredibly useful. So like this would have been otherwise, I build up my state by calling set in 3 times and replacing the variable every time with the new one. Well, now this is just a single one. I come back with new state and I return it. And the only reason I did the let and the return was I was debugging. But you could just certainly say return state out with mutations and you're good to go. So that made things really nice. Now I'm making 3 changes to the model and getting a new model reference with those changes in it. So that kind of made that interesting. So that's the reducer. Then everything else is basically a variation on the theme there. We're doing set ins and gets and things like that. So for example, with the missile location, if I destroy the missile, I want to basically set it so that the missile location has an empty space. And then the variables for the position of the row and the column of the missile are gone and 0, and then it's no longer active. So that's 4 different changes all in one nice little batch using state.with mutations. So to me, it just seems like if you're going to go down the road of really adopting the Redux pattern, that certainly Immutable is going to give you some advantages in terms of state management if you're willing to live within its restrictions, which are probably to your advantage.
It's a commitment, though, because now you've got all your code in this like proprietary library.
Good point.
And it's if something were to change and immutable objects were to come to JavaScript tomorrow, right? That's going to be a big change.
That's very true. That's very true. Well, otherwise you'd have to build your own or do something for the temporary period of time, or just not, just treat them as regular objects you do object assign with. So you're right.
There are some utilities out there that I've used in the past because I didn't want to go with Immutable.js because of that reason, that allow you to do these like deep dot notation setters and return like the object very similar to how Immutable does, but without that whole framework around that. So it's kind of like, then you can mutate your object and kind of cheat. So you don't get that like restriction, but if you wanted something lightweight and you just wanted to just handle the setters and things like that, there's a number of tools out there that do that type of thing.
Good to know. Good to know.
Well,
let me show. Yeah, go ahead.
Go ahead.
Yeah, so the effects. Let me just show you the effect. It was really just the missile animation for this one. So this was a little more straightforward and direct. And so this is the example of where if I trigger an effect, if I fire a missile, I want to pick up an effect and start animating that missile, right? So the goal here was when I intercept fire missile, switch to doing an animate missile call. And I'm using environment here for my data, so I can kind of jam it in one place for the time being. But I'm saying, whatever the number of calls is, do that minus, let's say 3, so it kind of fades out just before it gets to the ship, if it wraps around. And then what'll happen next is I look for the animate missile message. So that's basically going to come right on the heels of this. And it's going to basically count it down like we did in the other example. So, I wait a certain amount of time, and then I call another animate missile action, spaces left -1, until I eventually destroy it. And the interesting thing is, this isn't just doing this. The animate missile reducer method gets called, and that's what actually triggers the rendering, right? So the effect is triggering a reducer call with a particular action and state, and is also kind of going through a loop of calling it over and over again. So that's a little more refined and small example of doing that. But yeah, up until yesterday, or early yesterday, this was all using regular object assigns and stuff. But I found that the code got a little bit cleaner looking when I was going down the Immutable.js. So I can definitely see some advantages to it.
That's awesome.
Yep. As with any tool, you make your decisions based off of the size of the tool, what it's going to add to that versus the convenience it gives you in code.
Yep, absolutely.
Yep, give and takes, right?
Yep.
Cool. All right. Well, I think we're getting to the top of the hour, so probably need to wrap things up. Let's see.
Okay.
We'll stop presenting here. All right. Cool. Certainly a lot of material that could be other shows, right? We could probably do a whole one on Immutable.js and that concept and things like that, and definitely more on the ngAir. But definitely it was awesome to see this stuff. Appreciate you coming on and showing us this stuff and talking about it.
Thank you.
Let's get some picks. Austin, do you have any picks today?
I don't have any this week, believe it or not. I guess I gave all mine out last week.
That's totally fine. You had a ton last week, so we're good with that. Mike, you got anything?
I've got 2, and they're both very similar. So as many people are aware, Google I/O was last week. And I have 2 talks from there that I'm Adios Momini, and it's production web apps with JavaScript frameworks, where he walks through a different number of JavaScript frameworks and creating progressive web apps with those. He mentions Angular, but did not show any particular examples there. And then the other one is using web components with Angular with Rob Dotson and Stephen Thorman. They did a really nice job talking about how those 2 technologies play well together with each other. So again, those are in the show notes. You can find them out on YouTube, but both very good talks.
Nice. I have 2. First, a thought ram post on custom themes with Angular material that dropped. Pretty cool in terms of using Angular material and theming it, making different themes, different configurations and stuff for that. And then a little Overwatch love here. It's the 1-year anniversary event starting today and running for a couple weeks. So if you play Overwatch, check that out. All kinds of new goodies and stuff like that. Those are my picks. Ken, how about yours?
So my first one, and this is just to recognize the horror that just happened over in Manchester. If you feel as disgusted as I and everyone else probably on this podcast feel about the terror bombing at the concert last night, they have a support site on Westchester. I'm sorry, Westchester. What is it? It's called West End Together. I'll have to give you the link, but it's a PayPal giving site for crowdfunding to help the families, basically. So I'll put that in the show notes for you. I like this little thing here, this bare conductive touchboard, and it actually got me down the road of hacking web MIDI. This thing is I think it's about $70 or $80. It is a touch sensitive, basically static electricity touch sensitive switches that are hooked in as inputs to an Arduino. It also has a synthesizer built into it and little audio jacks and things like that. So if you're looking for like a nice little board to play around with Web MIDI or Web Audio or anything like that and hack it with some inputs, this thing is a really neat little project. It's also great for kids. So if you've got kids that are really interested in electronics, it comes with like paint, copper paint, and you can like draw your own keyboards and do all sorts of cool stuff. It is a lot of fun. So I'd recommend that as my second pick. And then my third pick, I'm actually going to sneak this in, is we had a really good blog post over at Chariot about Spring Boot and cores and a Jot that my colleague Rich Friedman did. And I think it could be really useful information just for the enterprise developers out there. It's on how to do security using Spring Security on the back end and Spring Boot with Angular 2, which I guess could be updated to Angular 4 by now, and using the JSON web tokens. That's a pretty useful little blog post.
And what site is that on? What's the domain for that?
ChariotSolutions.com in our blog.
Cool. And where can people find you on Twitter?
I'm at Rimple on Tech. And you can find me also on our blog as well. We do a lot of blogging on Angular and all sorts of other topics.
Awesome. Well, thank you so much for coming on. Really appreciate you sharing your time and sharing your code and taking the time. Very, very thankful.
Thank you very much.
We've got, we're going to be on the cruise. We're going to be recording, I believe, 3 different like panel shows, short shows. I don't think that they're going to be live because we're going to be on a boat, but maybe, I don't know. We'll find out. So if not, they're going to be up online as soon as we can get them recorded and stuff. And then the following week after that, we'll be back to our regularly scheduled Tuesday episodes. So thanks for joining in. Have a good one, and we will see you on the turn. Bye.